This is Josh White with JW Math Tutoring. In today's video, I'm going to go through 11 problems from the May 2025 Digital SAT Math exam. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Just before I begin going through these 11 problems from the May 2025 Digital SAT Math exam, I want to mention a couple of things. First of all, of course, if you like this video, please do click the thumbs up, subscribe to my channel, and sign up for notifications. Second, I've basically grabbed these problems, compiled these problems primarily from Reddit. So these problems that you see here might be slightly different than ones you saw on the test if you took it. There might be some details, missing or left out because, I can only go based on what students who took the test self-report. And lastly, there's some questions that I'm going to do as, a free response or a student-produced response, which on the test might have been multiple choice. So just keep in mind some of these questions, if they are multiple choice, there could be additional methods you could use to solve them that I am not going to show because I'm doing them as a free response question. All right. So with all that being said, let's go ahead and get started. Oh, sorry, one last thing. There'll be a link in the description and in the pinned comment for the PDF file that has all these problems in it so you can work on them before watching the solutions to this video. All right. So let's go ahead and get started here with question number 1. Basically, what we have going on here is a linear function and an exponential function. So f of x is the linear function, 3 to the x, g of x, is the exponential function, g of x is the linear function. And if you are familiar with the properties of each, basically, what happens, obviously a linear function increases at a constant rate the entire time, whereas an exponential function, will start off with a very, very slow rate of change, and then eventually it becomes much, much larger. So if you were to say graph these out, just to kind of give you a visual of what's going on, basically let's say you have your exponential function here, slowly increasing, and then it starts to take off, somewhere around here. And then you might have your linear function, which is going, increasing at a constant rate. Okay, this is not, it's going to need to be a little steeper. Sorry to go through this. Maybe something like this. Okay, so these 2 points of intersection, these are h, j, and k, l. Okay, h comma j is the first one, and then the k comma l is the second one. The reason you know that is because it tells us that j is less than l. Okay, notice j and l are the y-coordinate values. And the reason that it works out that hj is the first point is because 3 to the x, if you graph it out, and we can confirm this in Desmos, it's just going to be increasing as it goes to the right, and the linear function has a positive slope. Okay. Obviously, this would be different if we had a number basically that was between 0 and 1 for exponential function, and it would say it was decreasing, going down, looking like this, and or the linear function had a negative slope. Okay. So basically, we want to know which of the following statements here is true when f of x is less than g of x. Okay, so f of x is the exponential function. So actually, I should just do this in Desmos. There's no reason to really draw this all out when we can just get a much cleaner visual representation here in Desmos. Okay, so there's f of x. Now, for the linear function, you do have to actually pick something here. So what I chose is 2x plus 1, and then I will zoom in. And now we have a nice picture right here, okay? So when f of x, which is the red, is less than or below than g of x, which is the blue, okay, which of the following is true? Well, basically it's asking is which kind of region do the x values exist where that happens? In other words, where are the x values for which this is true? So if you notice, h is basically this 0 right here, the first intersection point. K is the x-coordinate of the second intersection point right here, which is 1. So this is true between 0 and 1, or in other words, where where x is between h and k. So the correct answer for this is going to be letter B, 2 only. It's not going to be true for the other two. And just to go back here again. So essentially, x is less than h would be this area over here to the left of, 0. Basically the, negative x values. And here you can clearly see that the f of x is greater than g of x. The exponential is greater than the linear. Same thing when you move to the right of k, i.e. to the right of positive 1, the exponential, here is greater than the g of x, or the linear function. So the correct answer for this, for which of the following regions is f of x less than g of x? And so the correct answer is just when the x value is between h and k, or in other words, between 0 and 1 for these specific values that I chose. All right. Next question, number 2. We have a polynomial function. They give us the intercepts. They want to know what the value of a happens to be. So one way to do this is to just set up basically all the factors. So we have our intercepts. Our factors are going to be like x minus c, where c is the intercept. So in other words, x minus negative 2, x plus 2, x minus negative 5, which is x plus 5, and x minus 7. And then you go through and do the actual workout. I'm just going to save some time on that. So basically foiling, this whole thing out, it's going to be x squared plus 7x plus 10. And then we have that multiplied by x minus 7. So now here, really we're only technically interested in the x squared term, for the a value. So you can just go and you can basically do x cubed, and then we get plus 7x squared. Now the other thing technically doesn't matter, so I'm just going to skip that, the plus 10x, so we can ignore that. So I just did these two, and then we can start here and do minus 7x squared. We don't need to do the rest, because notice what happens here, 7 minus 7, it actually turns out to be 0. So the correct answer for this one, for the value of a, is 0. Now, we could, of course, do this problem entirely in Desmos using regression. So what I'm going to do is I am going to regress, start with the intercept form. Plus 5, x1 minus 7, and then, okay, and now we're going to regress it to, I guess you would call standard form. Okay, and then for the last part, what we have to do is, of course, set up a list for x1, okay? And basically what this will do is tell Desmos to treat x1 as a variable, not as a constant, and therefore not return a value for x1. It only wants to return values, well, we only want it to return values for a, b, and c. So now you can clearly see here, a is 0. You don't have to do any of the work, multiplying it all out, the FOIL, combining like terms. You can just go straight to Desmos. You can do regression in it, and again, see we have the same correct answer here of 0. All right, next up, we have a question involving a circle. It actually turns out to be a very relatively short question with minimal work, because basically the translation to the right, 50 units, that does not affect the radius at all. That just shifts the circle to the right, but the radius is unchanged. So when you do that, it's in the new equation here, 7 is just the value of a. In other words, the number on the right side of this problem, it doesn't change, stays the same. So a is 7, so what's 4a? Well, 4a is just 4 times 7, it's 28. That's it. There's no other work to do. I mean, you could technically go to Desmos and you could like, put in, if you want to shift it to the right 50 units, technically you have to put in a minus 50 inside the parentheses, and you could do that, and you could see what happens. But the point is, the a value is not going to change. Radius is still going to be square root of 7, and therefore correct answer is just 28. All right, top of the next page, question number 4. Note this is a repeat problem. First saw this in March of this year, March 2025. So, a couple things. If you wanted to do this by hand, I will show that method first, and then I'll show, of course, how you could solve this in Desmos. So, first thing you would notice is when you plug in 0 for x, okay, you get negative square root 310 as your output. So, here, forgot the minus, 0 squared is just 0, b times 0 is just 0, and then we have plus c. Okay, so 0 plus c, that's just c. Therefore, notice c has to equal 310. All right, then you could take 2, 0 and plug that point in, and then you could go ahead and you could get 2 squared plus, it's going to be, b times 2, or 2b, and then plus the 310. And of course, that just ends up equaling 0. So now we've got 4 plus 2b plus 310 equals 0. 2b equals negative 314. b equals negative 157. Excuse me, type in, not grid in, of course, with the digital SAT. However, you can very easily do this problem in Desmos, so let's go ahead and take a look. Okay, so a couple things. First, if you're going to try to do regression with the square root, for some reason it causes some problems and some issues where if you just take the 2 points, even though we have 2 constants, and it should work, what you're going to see is that it's not going to work. Put this in here. Okay. Okay, slide this over. Let's zoom out. Okay, so let's just make sure I type this in. X squared, it's negative square root x squared plus bx plus c. Yeah, so this is not working. Notice it's not giving me, basically it's not giving me the 155 that I expect. Notice the r squared value is not 1. And the reason, it's something to do with the square root. So here are the ways around that. First, you can notice that when you plug in 0, the answer comes out to be negative square root 310, which means c is 310. So if you type in the c value here, then it fixes the whole thing. The whole thing works. Now you can go and you can see, okay, what's the greatest value of m? I.e., what's the largest 0? Well, it's just right here, 155. Okay, notice r squared is now 1. We have a perfect match. So that's one way around it. An alternate way around it, which you can do, is get rid of this negative sign, get rid of the square root, okay? Change this to a c, but now get rid of this. So basically what I'm doing is I'm putting in everything exactly as it is, except I'm getting rid of the square root. So I'm just pretending it's, equal to the quadratic. And now it gives me the correct values for b and c. The regression works out perfectly. Notice r squared value of 1. So now what's the greatest m, i.e. what's the greatest 0 or x-intercept or root value? Well, you just go to the graph. I mean, here's the 2 that we already know about, and the other one's 155. Okay, so this is a workaround that you could do as well. Okay, so let's go ahead and now take a look at question number 5. This is a repeat question. This appeared last year in 2024. I don't remember the exact month. I want to say August. But it showed up again on this May test. So let's go ahead and review it. All right, we have this right triangle here. I don't know if it's given as a right triangle or not in the problem, but if you do Pythagorean theorem, you can just verify it's a right triangle because a squared plus b squared equals c squared. So we have 3, we have 8, and we have root 73. Okay, so these side lengths of the right triangle are diameters of semicircles. And the total area of all 3 of these semicircles is w pi. What is the value of w? So essentially what we have to do is first take all these values, divide them in 2. So that's going to give us the radius values. So the radius values are going to be 3/2, 4, and root 73 over 2. Then we can take all of them. Remember, the formula for area is pi r squared, but because these are semicircles or half circles, technically you have to divide that by 2. So all I'm going to do, just to make the work a little bit easier, is I'm just going to take the 1/2 pi, and essentially, or pi over 2, move that kind of like out front. And then I'm going to go ahead and square the radius of each of these. So the 3/2 squared, 4 squared is just 16, and then the root 73 over 2 quantity squared is just going to end up being 73 over 2. Excuse me, 73 over 4. So you've got 1/2 times pi. You've got 9 over 4 plus 16 plus 73 over 4. So let's just go to Desmos and just do all the calculations in there. All right, let's get rid of this. So we got 9 over 4 plus 16 plus 73 over 4. And again, I could have taken the radius, the radii, and squared all of them, just added them up. But anyways, I get this value, 36.5 or 73 over 2. That's multiplied now by pi over 2, or by 1/2 pi, however you want to think about it. So if you do that, okay, you get this number. It's technically 73 pi over 4. You know, it's this, whatever this value right here is. But they want the number that's multiplied by pi. So w is just going to be 73 over 4, which you could also report as 18.25. Okay, so either of those would be acceptable. But now, if you're in Desmos, you're doing the calculations here, like if you multiplied it by pi over 2, I mean, you can just divide this whole thing by pi, and there we have our number, 18.25 or 73 over 4. Okay? Or just get rid of the pi out here, just worry about the rest of the stuff, just make this a 1, and there's the same number, 18.25, 73 over 4. Okay? But that should be the correct answer for W for that problem. Next, let's look at question number 6. This is a repeat question from one of the Blue Book practice tests. So basically what's going on here is you have a circle, you have a square inside the circle. Okay, the radius of the circle is 28 root 2 over 2. And so you notice what happens, 28 root 2 over 2. If you add two radii together, you get a diameter. And the diameter is the hypotenuse of the square. So, notice 28 over 2 plus 28 over 2. So there's multiple ways you could do this. You could, first of all, you could simplify it to 14. and then you could add them, and you could just see the whole thing's 28 root 2. Or you could add, like, 28 over 2, 20 over 2 becomes 56 over 2. 56 over 2 is 28. So however you want to think about it, basically you have a right triangle, and specifically it's an isosceles right triangle, with the hypotenuse being 28 root 2. So what are the side lengths? Well, if you know your 45, 45, 90 special right triangle, side relationships, these are just each going to be 28. Okay, and that's the answer. However, if you don't know that, if you don't remember the special relationship, but you recognize that for a square all sides have to be the same, you can just do Pythagorean theorem, and you could say, a squared plus a squared, set up a regression, and then over here is where we'll put the 28 square root 2 quantity squared. And it just tells us right away, okay, a has to be 28. That's our correct answer, so that's how you could just get it by using Pythagorean theorem and Desmos. All right, top of the next page, question number 7. Here we have another triangle-related problem, specifically right triangle and trig. So we have this isosceles triangle, okay, and we have AB and AC, which means point A is going to be up here. Here's B, here's C. Okay, and they're each 33 units long, 33, 33. And we have a 120-degree angle. Okay, this picture obviously is not drawn to scale, so just ignore that for right now. But this angle up here is 120 degrees. Now, that leaves 60 degrees to be split up between the two base angles, and they have to be congruent, of course, because they are each across from congruent sides. So we've got a 30 and a 30. It says if sine B equals P over 33, what is P? So all we have to do is just split this triangle right down the middle into two congruent 30, 60, 90 triangles. Again, the diagram is not to scale, so don't worry about that part. The 120 gets split into 60 and 60. So what is sine B equal to? Okay, sine B is equal to its opposite side right here. So this is P over the hypotenuse. Okay, so the hypotenuse is 33. Now, we also know that sine B angle B is 30 degrees. So we can just replace that right here. So the value of P is just going to equal 33 times the sine of 30 degrees. So if you know the sine of 30, it's just 1/2, if you haven't memorized from the unit circle. But if not, of course, you could just go to Desmos and just figure it out from there. Now, of course, this is not the correct answer because it's in radian mode. Make sure you click on the little wrench icon here, change it 2 degrees. And now you can see it's just equal to 16.5. And of course, you could enter it as that, or you could enter it as 33 over 2. So 33 over 2, correct answer. 16.5, also an acceptable correct answer. But both of those are what the value of P is equal to. All right, next let's look at another repeat question here dealing with the product of the roots for a polynomial equation. So first I'll show you how to do this by hand, then I will show you how to do this using Desmos entirely. So if you're going to do this by hand, you would notice that the various roots we have to multiply are going to be negative 8/5 from the first parenthesis, and then negative root 5 plus k from the second parenthesis, and then positive 5 plus k from the third parenthesis. And the product of all these roots is equal to 72. Again, the way we're getting this, I'm basically just taking each parenthesis and setting it equal to 0 and then solving for x. Okay, so notice a couple things here. First, two negative signs will cancel out and just make everything positive. Okay, so I'm just going to get rid of that. I'm going to get rid of that just So it's not causing confusion, and we think something being added when they're really being multiplied. All right, I can also multiply by 5/8 on both sides. So this and this cancel out. On the right side, you should get 45 because 8 goes into 72 9 times. 9 times 5, 45. Next, square root of the identical expression twice, or i.e. the square root of something squared, just becomes that expression. And then we can easily solve this and get k equals 40. So that's the value of k. It's actually not that much work. You can see here to do it by hand. However, we can, of course, do this entirely in Desmos. All right, so what we need to do is the following. We're going to take the original equation that we're given, and we are going to do a regression where we regress it to its intercept form, or basically its factored form. The reason we do that is because it allows us to define the various roots. Okay, so let's put an m out here. And then we got x1 minus a, x1 minus b, x1 minus c. A, b, and c here represent the 3 roots. You know, and the fact that there's 3 roots is because there's 3 parentheses. And the 2/7, that's just a constant. There's no variable in there. All right, now what we need to do is define an equation with those roots. So we know that the product of the roots, so a, b, c together equals 72. Except this doesn't help us. We need to define one root in terms of all the others. So I'm going to divide by BC. Okay, so now this is what we need to do, basically for the second step. Also, we'll mention if you want to see more about using product or some of the roots, check out the video in my Ultimate Desmos Guide to Digital SAT Math. There's a video that covers this topic along with some others that goes through problems in detail, but for sum of roots and product of roots. Now the last step, we have to define x1 as a list. And I always, for these problems, start with -2, 0, and 2. Let's add some more random numbers. Okay, now notice it's working out perfectly. We don't really care so much about m, b, c, or a. What we're concerned with is the value for k. And right here, once we have enough values entered in for all of our various constants, we get k equals 40, which is the correct answer. So this is how you could do this entire problem in Desmos and solve it. All right, next up, question number 9. Here we have a problem that, again, it's a repeat from one of the Blue Book practice tests. It showed up last year. Hadn't seen it mentioned in a while, but it did show up apparently on this test. So we have a circle. Down here, okay. All right, we know that the center of the circle is point G. And then there's points A and B, basically, which are on the circle. And essentially what's happening is there's a point out here, point H, such that you connect H to A, which is tangent to the circle, and you connect H to point B, which is tangent to the circle. Then you draw the radius from the center to this tangent point on both sides, tangent points, I should say. And it ends up forming 2 right triangles. So that's the one piece of information you do need to know in order to solve this problem. That when you draw the radius from the center of a circle to a point of tangency, it is perpendicular to that tangent line. And the other thing you need to know is basically, you know, when you draw this line down the middle here, okay, connecting G to H, notice we've made basically two congruent right triangles. However, the key is, the other thing you have to know, this is a kite, and specifically these 2 side lengths are congruent. And the reason is because if you have a point outside of a circle and you draw basically to a point of tangency, two different points of tangency on the circle, those line segments from the point outside the circle to the point of tangency will be congruent. That's the geometric principle or theorem that you need to know in order to solve this problem. All right, so we know the radius is 500, so we can fill this in 500, 500. Now what you do is you subtract that away, so 3400 minus 500 minus 500. That leaves you with 2400. Of course, you can do this in Desmos. That's for the two remaining sides, HA and HB. They're going to be equal or congruent, so you divide them in half. So that means you get 1200 and 1200. Now you have a right triangle, but be careful, this side in the middle, this is the hypotenuse, this GH that you're solving for. Okay, 1200 is not the hypotenuse. This side in the middle across from the right angle is your hypotenuse. So I would just go to Desmos here. Let's get rid of this. And I just know that we have 500 squared plus 1200 squared, and do a regression, and it's c squared. Okay, so the value of c, i.e. the distance between G and H, is 1300. So that's our correct answer. Of course, we just fill in 1300. And that's it. This is pretty much the only way I know to do this problem. I don't think there's any other real alternate methods that you can use to solve it. All right, let's go to the top of the last page. Let's look at problem number 10. Here we have a percentage problem. We've seen a lot of these actually going back last year and also on the Blue Book practice test as well, where you have like 3 different constants, and this one's a percentage of that one, and that one's a percentage of a third one, and so on and so forth. So on this one, if you want to do this by hand, which I'll show first, basically what we have is A equals, now 474% is just 4.74 as a decimal of multiplication B. And we also know that A is equal to 0.79%, or as a decimal, 0.0079 times of his multiplication C. Now, the question is asking if C is P% of B, so we want C and B in the same equation. So since these are both equal to A, I can just set them equal to each other. 4.74b equals 0.0079c. Here's the trick, or here's the key. C is. That means you want C equals everything else on the other side. So we need to divide by 0.0079. C equals. And when we go ahead and do this, you're going to get, and we can just confirm this in Desmos, should get 600b. 4.74 divided by 0.0079. Yep, okay. But we want P as a percentage, not as a decimal. So P is 600, but we want the percentage value. So that's where you have to multiply it by 100%. So the final answer to this is 60,000. That's what you would type in. Okay? So P as a percent is 60,000. However, like most percentage problems, we can of course solve this problem in Desmos. So let's see how we can do that. All right, first thing I'm going to do is just type the original equation, or the first equation, which is the A equals, and you can leave it as a percentage, 474% of B. Then I'm going to define B as 100. And then for the next, where normally you would type the equation with C, I'm instead going to do a regression. The reason I'm going to do a regression is because it will then take the value of B that I've provided, and it'll find the value, and which it used to find the value of A, and it takes those two values and it uses that to find the value of C, which is what we're looking for. So notice here I get the correct answer of 60,000 right away as C. The reason it works out like that is because I chose 100 for B. Okay? So in these percentage problems where you have something like if C is P% of B, or B is P% of C, whoever it is. For the number that you're solving for, like for the C, for the letter, for the other letter, you want to pick 100 as your starting value. If you pick 100 as your starting value and you set it up and work through it like this, it should give you the correct answer for the percentage or whatever that you're trying to find, because basically I picked 100. So this is how you could do this problem entirely in Desmos, basically just 3 lines and that's it. All right, the last question, number 11, deals with a pyramid, specifically a pyramid with a square base. And essentially what's going on here is they give you the total surface area, they give you the surface area of the 4 lateral faces, so I'll just call it the lateral area. It's basically the 4, triangles, and they want to know the height of this pyramid. Okay, so what do we have to do in order to solve this is first subtract these 2 figures in order to get the area of just the base, basically the square base. So if we just go ahead, we'll do that in Desmos. Okay, I get 9216. Now, the reason why I do that is because since the base is a square, we can just square root this, and that will give us, the sides. I mean, they're equivalent. The length of the side of each base. I'm just going to raise it to the 1/2 power. Okay, so I get 96. So this is 96. Okay, this is 96. All right. In order to find the height, so the height is coming down here. Okay, so we have the height, and then basically we will also need to find the slant height. Because basically what's going to happen is we're going to make a right triangle with the height, the slant height, which is technically the height of one of the triangular faces, and also half of one of the sides of the base. So like this bottom thing right here is going to be 48 because it's half of 96. So the height is in the middle, even if my picture is not showing it. So again, it's basically going to look like this. 48, slant height, height. So we need to find the slant height. Once we have that, we can just use Pythagorean theorem to find the height. Okay, how do we find the slant height? So we need to take the lateral area, which is the area of all 4 triangles, and we need to divide that by 4. So 11,520 divided by 4, 2880. So that means the area of one triangle, or one triangular face, is 2880. And the area of one triangular face is 1/2 base times height. Just kind of like highlight this right here. Okay, here's a triangular face. Base, we know, is 96. Height, that's basically the slant height. That's, this thing coming down right in the middle here, perpendicular. That is the L that we are solving for. So half of 96 is 48. So the slant height is just going to be 2880 divided by 48. So let's just jump back here. So I could just take this whole thing, divide it by 48. We get 60. All right, so the slant height is now 60. So get rid of this. 60. Okay, now we can just set up Pythagorean theorem to solve for the height, of the overall height of the pyramid. So we have h squared plus 48 squared equals 60 squared. Let's just go to back to Desmos and just do a regression. Slide this over so we can see it. Okay, h squared plus 48 squared tilde 60 squared. All right, I get the height equaling 36. So that would be your correct answer for the problem. Technically 36 inches, but 36 obviously is all you would type in. And just to, again, briefly review, you take the total overall surface area, you subtract from that the lateral surface area, that gives you the area of just the base. You square root that in order to find the length of the side for each base, because it's a square. Then you take basically the area of one triangular face, which is the lateral area, divided by 4. You set that equal to the area formula for a triangle, 1/2 base times height. We know the base is 96. We just found that. The height in that equation is the slant height. Once you find the slant height, then you can take the slant height, you can take half of one of the base sides, half of 96, which is 48, and you can use Pythagorean theorem to find the height of the pyramid, which turns out to be 36. All right, so I hope you enjoyed this video going through these 11 problems from the May 2025 Digital SAT math test. If you did like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Of course, if you have questions or comments or alternate solution methods, please feel free to leave them in the comments section below. Otherwise, be on the lookout for the videos going through worksheet number 2 and worksheet number 3. And also, of course, check out my Ultimate Desmos Guide to Digital SAT Math if you want to learn more about how you can use Desmos to ace the Digital SAT Math section.